In the present video, I'm going to introduce the use of the Statistical Tools plugin and show you how to produce some statistical graphics, actually probability graphics more likely, with the Plot XY application. We're going to start with this particular worksheet. We are introducing the use of plugins in this series of videos, and I mentioned 3 plugins that are of interest, and those are, as indicated here under plugins, there it is. No, that one. The next one, the Statistical Tools. This one called Table Region is not loaded yet, but we got the XY. With the Statistical Tool and the XY, we can proceed with these examples. In probability, there is what is called the probability mass function for discrete random variables. Specifically, what is called the binomial distribution. The function that provides the probability mass function is this expression. To type this expression, you just follow your intuitions here and say f of x space a colon n exclamation mark divided by x exclamation mark times parenthesis n minus x space bar exclamation mark space bar times p raised to the x space bar times 1 minus p space bar raised to the n minus x. That's it. All what I did here is change the color of the A to blue. Okay. Associated with the probability mass function, there is the cumulative distribution function, which is the sum of the probability mass functions from the minimum value available, which is k equals 0, to x. K here is a dummy variable that actually it should be for, no, it's okay, for x. It just represented the index of the summation. The range of values that the independent variable x or the random variable x can follow is from 0 to n. And so this expression, which is typed as xx colon range parenthesis 0 comma n for n equal 10 in this case and p equals 0.3, will give me my vector from values from 0 to 10. That's what I have in here. I'm going to delete this one. Then, to obtain the corresponding discrete values for the probability mass function and the cumulative distribution function, I'm just going to evaluate those functions. Double lowercase f column f of xx space bar apply vectorization uppercase double uppercase of x space bar apply vectorization, and then I'm going to produce matrices to plot these two functions. mxf augment xx with ff, and mx uppercase f is the augmented matrix resulting from putting together xx with uppercase double f. That's what I have here. Now, if we want to see what those matrices look like, type mfx equal, and so it shows the cumulative, the probability mass function, and mx uppercase f Oh, this case not defined. Oh, of course, because XX should be here now. And so with that, I get mx uppercase F as my probability cumulative distribution function. I'm going to delete these two because I want to put graphics showing those probability distributions using plot XY. So I'm going to click in here, go to tools, insert, plot, XY plot. And down here, type the matrix MXF. And now I have to do some adjustments in here. Let's see, we start with labels. X is okay for the Y label would be, we can call it probability mass function PMF f of X. Okay. Then we go, what else are we going to use here? Title. Binomial PMF. For traces, there's only one trace, but I want to make it so that the line doesn't show up, which means going up here and make it transparent, but that symbols show up in the form of a circle. Okay. For the x-axis, I'm gonna go with 1 decimal place up to a maximum of 10 with a minimum of 0 with increments of 1. So I'm showing all the values of that function in there. The PMF. For the vertical axis, I don't have much. I'm just going to go to 0.5, so 1 decimal place, maximum of 0.5, minimum of 0 in increments of 0.1. And so that gives me actually I just need to go to 0.3. This just need to go to 0.3. And shows the variation of the probability mass function. I'm going to copy this, Control C, click over here to Control V, and make some modifications. For example, I'm going to start with the labels, and the Y is going to be called CDF, the cumulative distribution function, f of x, uppercase of x. Then, something that I should have done over here is change this to mx uppercase f. That I'm going to need to go up to 1 for the vertical scale, so I'll go here and go for y-axis from minimum of 0 to a maximum of 1. And at 6, we're going to put every 0.2. And so here we have our function, the cumulative distribution function for the binomial. The only thing I need to change here is the title of the graph to binomial CDF. And so this is an example showing some probability data and using the XY plots. Now, I haven't used any function from the statistical tools. But if you can see in these graphics, if you go to, and you're just going to click here, go to the function f and look under all functions, and scroll down to the P's, you're going to find something called PDF binomial. 2, it says returns the binomial PDF for cases with number of trial and number of successes. So this is just giving you the total distribution, and I need this one, the PDF binomial 3, where you provide the X, the N, and P. And so you will select this function and say insert, and then enter the my values of X, which is this vector XX, N and P, which are the parameters of the distribution. Then press the space bar to select and use the vectorization, and if you make that equal, it gives you the probability mass function for the binomial, which is calculated right here. I repeated my ranges of values from 0 to n, and then I call it FB for the binomial probability mass function. And in this listing of variables, if you look for the C, you're going to get the CDF binomial with 3 elements, and for that you're going to use the XX, N, and P. Space bar, vectorize, equals. Let's give me the values right here. Okay, I'm going to show them over here. What I'm done here is repeat that operation and storing the results into a variable, which is a vector called FV, and then uppercase FV, and producing matrices, augmented matrices XX FV and XX uppercase FB actually here. And then I have plotted the matrices for the 2 matrices that I generated for the binomial distribution using my user-defined functions right here, these 2, which are these 2 graphics. And this is the data using the statistical tool function, which is these 2 matrices right here. And I'm going to need to check something here. I may have messed up. No, those are the 2 functions. Let me repeat this here. I actually have changed my ranges here, so I'm going to need to fix that. Somehow I messed them up, because it should go from 0 to 10. Takes up 1. And for the y-axis, we're going to go from 0 to 1. Actually, to 1.2. And as you can see, this graph is a little bit larger, and then all right. They produce exactly the same graphic. And so the statistical tool has the probability mass function that they call probability density function, and the cumulative distribution function for the binomial, and many other and many other distributions available. And for example, here's the PDF binomial complete for the values of NP that we have here, which are N equals 10 and P equals 0.3. If I change this to, let me get that P out of there. Change that to 0.5, for example. I get my data to change. Oh, of course. This is just showing the value. I will need to do P colon 0.5, and that will change my data. Anyway, I just wanted to demonstrate that. I'm going to remove this and this. And this is another way to generate the graphic by using the function PDF binomial, CDF binomial. There are many other functions in the statistical tool package, and we're going to be presenting them later on. I just wanted to demonstrate a little bit of the statistical tools together with the plot XY cases.